facing. So that's where that comes from. So this is my solution here, that x is greater than or equal to -2. Now we can represent this on a number line. So I would just want a visual drawing, a visual representation. So I put -2 over there. So my solution x is all the numbers that are bigger than or equal to -2. So I draw a circle. My circle is shaded because of this line that I have over there. So it's a shaded circle. And then bigger than means I'm going to the right. So I draw it like that. And it's an arrow because it shows that I never stop. I just keep taking bigger and bigger numbers. Okay. So it's from -2 onwards to infinity. Number 2 over 3x plus 1. This is greater than half x minus 3. So again, collect all your terms with x on one side, everything without x on the other side. So what you do is you subtract half x on both sides. So you have 2 over 3x minus half x. The inequality should still face the same direction, and then you subtract 1 on both sides. So I have -3 minus 1. Then I combine my terms. This is 2 over 3x minus half x. This should give you 1 over 6x. This is greater than -4. Okay, so here, trying to get rid of the denominator, I can multiply by 6 on both sides, multiply by 6 on both sides. Now, when I multiply or divide by a positive number on both sides, the inequality must remain the way it is. So what I have is this, x is greater than -24. So we can look at an illustration of this. If I say again, -2 is less than -1. If I were to multiply this by a positive number, let's say 3 times 3, you can see here I have -6, and then here I have -3. And -6 is less than -3. So my sign here does not change when I multiply with a positive number. So it only changes direction if you multiply by a negative number. Okay, so this is my solution over there. What I need to do now is to draw a visual representation of the solution. So I draw my number line. It's 2 arrows, one pointing to the left and the other pointing to the right. And then I will put -24 on the number line. So there's -24. And then my circle on top of 24 is not shaded because this is strictly greater than. It doesn't have the line underneath. When I have the line underneath, my circle is shaded. So here my circle is not shaded, and I'm looking for numbers x that are bigger than -24. That means they must be on the right hand side, which is this side. And then I show an arrow to indicate that I am increasing. It's just getting bigger and bigger. It doesn't stop anywhere. Okay, so it just goes to infinity. And let's look at some of the exercises. Exercise 4.6.1. We have 3a plus 7. This is greater than a minus 5. So again, all the terms with a on one side, everything else on the other side. So I will subtract I'll subtract a on both sides. This is number 1. So I have 3a minus a. The sign should face the same direction because adding or subtracting anything, whether it's positive or negative on both sides, doesn't change the direction. And then I have minus 5 minus 7. So I subtract 7 on both sides. Then what I get here, this is 2a. This is greater than minus 12. And then I divide by 2, divide by 2. I get a is greater than minus 6. So again here, dividing by positive number does not change the direction of your sign. The sign only changes direction if you multiply or divide by negative number. In here I'm dividing by 2. 2 is a positive number, so my sign should not change direction. So this is my solution, and I can draw a visual representation. Draw your number line, then you put the number that you got over here, which is minus 6. Then you draw a circle on top. Your circle is not shaded because there is no line under the greater than symbol. Now we say a is greater than minus 6. So it must be numbers that are bigger than minus 6. So you go to the right of minus 6. And the arrow just shows that you continue on. Okay, so it should have that arrow to show that if you keep getting numbers that are bigger, it never stops anywhere. Then number 3, we have 3x minus half. This is less than or equal to half x plus 4. Okay, again, all the terms with x on one side, everything else on the other side. So I will subtract half x on both sides. So I have 3x minus half x. This is less than or equal to 4 plus half. So I also add half on both sides. Now 3x minus half, that is just 2.5. So this is 5 over 2x. And this is less than or equal to 4.5, which is 9 over 2. Then you divide by 5 over 2 on both sides, or you can say multiply by 2 over 5 on both sides. Either way is fine, but 5 over 2, 2 over 5, those are positive numbers, so multiplying or dividing by them doesn't change anything. So here, if I multiply by 2 over 5, multiply by 2 over 5, it will not change. You can see the 2 will cancel, the 5 there will cancel. I'll be left with x is less than or equal to 9 over 5. And then I represent this on my number line. So 2 arrows, one going to the left, the other one going to the right. 9 over 5 is somewhere here. Then my circle on top is shaded because I have this line here. It can be equal to 9 over 5. That's allowed. So that's why my circle is shaded. Then I want numbers that are less than that. Less than 9 over 5 means to the left of 9 over 5. So I'm going to the left. And my arrow just shows that I keep going. I don't stop at a specific number. So I'm just going towards negative infinity. Number 5, number 7, plus 2 times 5 minus 3m. This is greater than 6m. Okay, now to solve this one, I just like I would with a linear equation, I must multiply out my brackets and then take all the terms with m on one side, everything else on the other side. So this is 7 plus 10 minus 6m. This is greater than 6m. Okay, so here I can combine these two together. I get 17 minus 6m. This is greater than 6m. Then what I can do is I can add 6m on both sides. So I have 17. This is greater than 6m plus 6m. and then I have 17 is greater than 12m, and then divide by 12 on both sides. And remember that 12 is positive. When I divide by a positive number on both sides, the inequality does not change direction. So here I just have 17 over 12 is greater than m. Now this one here, 17 over 12 is greater than m. You can rewrite it as m is less than 17 over m. So these two are saying the same thing. If 17 over 12 is greater than m, it means that m is less. Why do I have m there? If 17 over 12 is greater than m, it means that m is less than 17 over 12. That's the same thing. So let me just do a quick illustration. If 2 is greater than half, then half is less than 2. So this is basically the same idea that I'm using. Then what you do is you rewrite this or represent this on your number line. So we have our number line over there. I have 17 over 12. Then on top of 17 over 12, my circle is not shaded because this m must be strictly less than 17 over 12. And then I go to the left of 17 over 12 because I want numbers that are less than 17 over 12. And that is it. Okay, do we have questions on that one?
No, it's fine, ma'am.
Okay, that's good. Right, then now we move on to quadratic inequalities. Now this one is similar to quadratic equations, but we will do them in a little bit of a different way, or we'll do some extra things. With quadratic equations, if it was factorized, first thing you would do is collect everything on one side, 0 on the other side. If it was possible to factorize it, you would factorize it. After that, you'll say the first bracket is 0, the second bracket is 0, and then you'll solve. Now with inequalities, we will also take everything to one side, 0 on the other side. We will factorize, except this time we will not say the first bracket is less than 0, the second bracket is less than 0. We will do something a little bit different. Now let us look at an example. I have 9x plus 2. This is less than 4 minus 4x plus x squared. So this 9 should multiply inside the brackets like that. So I have 9x plus 18. This is less than 4 minus 4x plus x squared. Then what you want to do is you want to subtract 9x on both sides, and you also want to subtract 18 on both sides. So on the left you'll have 0, then on the right you'll have x squared because it doesn't have any like terms. Then this 9x, when you subtract it with from the negative 4x, you'll have negative 13x. And then this 18, when you subtract it from 4, you have negative 14. Now this inequality, I can rewrite it. So here, this is what I have. I can rewrite it as x squared minus 13x minus 14 is greater than 0. Because over here, if 0 is less than this, it means that this is bigger than 0. That's what it means. So I'm rewriting it like that. And what does bigger than 0 mean? if something is bigger than 0, it means it is positive. If something is less than 0, it means it is negative. So let's keep this in mind. So it means that this is positive. Okay, so that's what it means. When something is bigger than 0, it is positive. If it's less than 0, then it is negative. So this is how we would do a quadratic equation. Everything on one side, 0 on the other, then factorizing. Now this one, we look for two numbers that when you multiply them, the answer is negative 14. And when we add them, the answer is negative 13. So those two numbers are negative 14 and positive 1. So you open your brackets, equal to 0. You put your x, then your two numbers, we said it's negative 14 and positive 1. Then, sorry, I'm going back to equations, should be greater than. So I've factorized this. So don't make that mistake of putting equal to. We use the inequality. So I have factorized the quadratic part. The inequality here is still the same one over there, and I still have 0 on the other side. Now that I have factorized it, what I'm not going to do is this. I'm not going to say x minus 14 is greater than 0 or x plus 14 is greater than 0. This is not correct. Okay, what you do now is look for what we call critical points. Okay, now these points are critical. The word critical means important. They're critical in that they divide the number line into 3 different regions. Now to get these critical points, what I do is I will say the first bracket is equal to 0. This means that x is equal to 14. Then the second bracket is equal to 0. This means that x is equal to minus 1. Okay, now this values x is equal to 14 and x is equal to minus 1. These are my critical points. They are important. So what they do is they take my number line and then they divide it. So I put the numbers 14 and negative 1 on the number line. Negative 1 comes first, and then 14. So let me just make space. So negative 1 goes there, and then 14 goes over there. That's the order that they appear on the number line. Negative 1 is smaller than 14, so it must be on the left of my number line. So notice what happened here. I had a number line from minus infinity to infinity. Then when I put the two numbers there, my number line is divided into 3 regions. So I have this region here, which is that one there. I have this region here, and then I have this region over there. Now the region in red, these are values x. These are values x that are less than minus 1. That is my red region. Now my orange region, these are numbers between minus 1, but they are less than 4. So you can see if I pick a number in the orange region, it is between negative 1 and 4. And then in the yellow region, I have numbers that are bigger than 4. That's what I have. Okay, so these numbers, they are important because of what they do to my number line. They divide it into 3 specific regions. Now what I'm going to do, just like we have the country divided into regions, we have the 14 regions, Commerce, Erongo, and all of them. in each of the regions, you have a government or people that determine what happens in the region. Now, in those regions, you have a person that speaks for the region. So you maybe have a governor. So the governor says, okay, this is what my people in the in the region say. So this is how Irongo votes. Commerce also says the same thing. I speak for the people in commerce. Then he decides what commerce will do. So if the president asks, what will we do as a country? He'll talk to all the governors. The governor will say, in my region, this is what we want. Commerce will say this, in my region, this is what we want, and so on. Now, this is what what will happen here in our number line. So I will draw it again. So I have my number line over here. Say it's divided -1, and we have 14. Is it 14 or 4? So this is 14. I didn't see that. Like that. That's a 14. Okay, so what you do is, just like you have a governor in all the regions, even here in my number line, you must pick the representative. Now your representative must be somebody in that region. You cannot say you're the governor of Irongo, but you're here in Windhoek. It doesn't work like that. It must be a person from that region. So here, when I pick a representative in the red region, let's say I pick -2, because -2 is less than -1. So it is in that region. The person you pick doesn't matter as long as the person is in that region. Then in the middle one, I can pick 0 because 0 is in that region. And then in the third one, let's say I pick 30 because 30 is in that region. Okay, now what will happen is, just like the president is asking this region, how do you vote? The person will say, in our region, this is how we vote. And then at the end, we count all the votes and then we decide, does the law pass or something like that. So what I do is, these brackets that I factorized over here, these are like the laws that you want to pass. So what you do is you're going to present them to each of the representatives. So the first law is x minus 14. The second one is x plus 1. Okay, so I'm going to extend the table, this, so I end up with a table like this. Just extend it like that. Okay, then you will substitute each of these values in there and also in there. Now you're not interested in the answer, whether it's -25 or -100 or what the actual value is. All you're interested in is whether your answer is positive or negative. That's it. So that's the vote. So the governor will say, yes, our vote is yes, or he'll say, no, our vote is no, something like that. So the value of it, whether you strongly agree with it or strongly disagree with it, or you moderately agree or moderately disagree, doesn't matter. We're just interested in, is it positive or negative? So when I do that, I will substitute -2 into that one. -2 minus 14, this is -16. So this person will say, in our region, we will vote negative, no. Then you do the same thing, -2 into this equation over there. You have -2 plus 1, that is negative. Then you move on to 0. 0 into the first equation, you will get negative because it's 0 minus 14, -14. Then for the second one, 0 plus 1, this is positive. And then 30 minus 14, this is positive. 30 plus 1, this is positive. Then what we do over here, we go back to our question. My question over here with these two brackets, they are multiplying. So the final stage is multiplying. So I put x minus 14 times x plus 1. So what I do is what they said over here. This region said negative, this one said negative. When I multiply negative with negative, my answer will be positive. Then here again I say negative times positive, this region will be negative. And then positive times positive, this gives me positive. Then these are the final solutions here, these ones. But I'm not going to take all of them. What I'm looking for is here. When I multiply them, I should get greater than 0. And we said greater than 0 means positive. So I go back to my table and I look for the region where I was multiplying. So it's in this line over here, this row over here, where I was multiplying and then my answer came out as positive. So the first will be the red region over here, this red region over here, because the first answer was negative, negative, and then when I multiplied it, my answer was positive. And then the yellow region as well, the people both gave positive, so when I multiplied it, positive. So it's like you're looking for where the governors agreed, not whether they said yes or no, but did they agree on what they said? So in the first one, they both said no, that means they agree. And in the last column, they both said yes, that means they agree on that. So that's what we're looking for. Then this is positive, that is positive. So the solution to this will be this region here where I got a positive. This was x is less than negative 1, or x is greater than 14. So that would be your solution. Now you can pick a number in this region, in any of those, pick one there and another one in there, and then check, substitute it back into your original equation. You will see that it does satisfy your inequality. But if you pick a number in there, it will not satisfy your inequality. So this solution over here, we can represent it on a number line. Draw this, make two numbers, negative 1 and 14. And we said we want numbers that are less than negative 1. This is open, going that way. It is less than. The reason I put less than is because from my question, I did not have less than or equal to. I had strictly less than. So that's why when I give my answer, I give it strictly less than. And then the same thing over here, we said it must be greater than 14. That means on top of 14, I have an open circle and I want numbers that are bigger than 14. So let us check our solutions. So I want to check. Now the inequality after we'd simplified it was this, was x squared minus 13x minus 14. So we want to check if we pick a number in this region or a number in that region, does it actually satisfy? So the number you pick doesn't matter because that person is in that region, so they speak for the entire region. So let us pick, let's say, negative 3. Now when I pick negative 3, I substitute it in there. So remember, we want this to be positive, greater than 0. So I'll substitute negative 3 there, negative 3 over there. So I have negative 3 squared minus 13 times negative 3 minus 14. So this you do on your calculator. Negative 3 squared is 9 minus 13 times negative 3 minus 14. This is equal to 34. Okay, and you can see 34 is greater than 0. So our first choice from this region is correct. Then I can pick a number in this region. That means pick a number that is bigger than 14. So let's say 15. So you substitute it, you have 15 squared minus 13 times 15 minus 14. 15 squared is 225 minus 13 times 15 minus 14. This is equal to 16. And again, 16 is greater than 0. But if you were to pick a number that is in the middle region over here, let's say you pick 0, because 0 is between minus 1 and 14, what I have is this. If x is equal to 0, so you have 0 squared minus 13 times 0 minus 14. This is equal to negative 14. Negative 14 is not greater than 0, so that shows that this is not a solution. Okay, so here I picked random numbers. You can try it with more numbers. As long as they're in that region, then they will always satisfy it. So pick minus 20 over there, minus 50, minus 1 million if you want to. Same thing on this side. Pick 1,000, 10 million, 3 billion. It doesn't matter. And then in this region, pick half, pick 7, pick 2, pick 10. You will see that it doesn't satisfy. And the way we get this is by using what we call a sign table. This is known as a sign table. So you can see it is a table because it has rows and columns, and the entries in our table are signs. Do we have questions on that one? Or is it fine? Okay, sounds like it's fine. Let's do another example. So let's say we have x plus 1 squared. This is less than 6x squared plus x plus 1. So here again, what you do is you will have to rewrite it in the standard form where you have all the terms on one side, 0 on the other side, and then you will factorize. With these quadratic inequalities, most of the time you will be able to factorize, but even if you're not able to factorize, you can use the quadratic formula to work out your critical points. So what we do over here is first I must multiply this bracket out. So we know how to multiply our bracket out. Say this is x plus 1 times x plus 1. The x with the x with the 1 with the x, like that. So you get x squared plus x plus x plus 1. This is just x squared plus 2x plus 1. So that's what you have on the left hand side of your inequality. So I have x squared plus 2x plus 1. This is less than 6x squared plus x plus 1. Okay, and then what you do is you will take everything to one side, 0 on the other side. So what I will do is I will remain with 0 on the left hand side. Then I subtract x squared on both sides. So I'll have 5x squared. And then I will subtract 2x on both sides. Then I will have minus x. And then when I subtract 1 on both sides, this one and that one, they cancel each other out. I'll be left with 0. Now this equation, I can rewrite it as 5x squared minus x is greater than 0. So if 0 is less than this, it means that this is greater than 0. Then I must factorize it. Here we can see x is a common factor, so I factor out x. and then I have 5x minus 1. This is greater than 0. Then what I do is I look for my critical points. Now the critical points, those are the values that make this equal to 0. So I have x is equal to 0, or 5x minus 1 is equal to 0. Now if 5x minus 1 is equal to 0, this means that x is equal to 1 over 5. So those are my critical points. Now with the critical points again, I draw my number line, and they divide my number line into 3 regions. I put them in order. I have 0, and then I have 1 over 5. I have 1 over 5. Then the brackets that I factorized, or my factors, I put them here. I put x, and then I have 5x minus 1. So I make a table like that. Then you pick a representative in each of the regions. So the first region, which is this one here, that's numbers that are less than 0. So do not pick the border towns, because border towns, or the border numbers, border towns are always not reliable, I guess, because you can identify with both sides. So you'll get a 0 if you substitute the border ones. So you must pick something inland. Okay, so pick a number less than 0, let's say -1. And then in this region over here, between 0 and 1 over 5, let's say 1 over 10. And then a number bigger than 1 over 5, let's say 1. Okay, so that's that region over there. All right, then you substitute each of them. You'll substitute -1 into x. You're not interested in the actual value of the answer, but in whether it is positive or negative, because it's a table of signs. So you're only interested in the signs that you get out. So when you do that, -1 into x, you just get -1, which is negative. -1 into 5x minus 1, so it's 5 times -1, it's -5, minus 1 is -6, so I get a negative there. Then 1 over 10 into x, that is positive. 1 over 10 over there, this gives me a half minus 1, which is -1/2, so that's negative. And then 1 into there, I get positive. And then over here, I also get positive. Okay, then if I go back to my bracket, the way it looked, I was multiplying. So the same thing should happen over here. So I should multiply them. So it's x times 5x minus 1. So I want to find out what is happening when I multiply the opinions, if you will, of the x and the 5x minus 1. So I have negative and negative. This gives me a positive. Positive and negative. This gives me a negative. Positive and positive. This gives me a positive. Now to decide the one that you want, it's not always the positive ones or the negative ones. It's not. It can be negative or it can be positive. Now the one you want, you go back to your question after you factorized it. You go here. This is how it was when I factorized it. We said, sorry, not that one. It's this one here. This is what I got when I factorized it. And I said when I multiply them over here, I want the answer to be greater than 0. Greater than 0 means positive. So you go into this row where you have the row where you have x times 5x minus 1. And then you look for the regions where it is positive. So we go to our table, the row that has them multiplying, it's not this row because this row is just x. This row is just 5x minus 1. But this row over here has 5x minus 1 multiplying by x. This is the row that you want. Then you go, the first column is positive. that's what I want, because when I factorized it, I say that my answer must be positive. So I tick it to show that that is what I want. In the second column, this is negative. That means when I multiply these two, the answer is negative. That's not what I want. So I cancel it out. Then in the third column, this is positive. So I'm multiplying them and I'm getting a positive answer, which is what I want. And again, what I want comes from what I have over here. After it is factorized, I said it must be greater than 0. So that's where that comes from. Then I can see that the regions that satisfy the product being greater than 0 is from 0 to minus infinity, or from 1/5 to infinity. So I must have x being less than 0, or x being greater than 1/5. And then when I represent this on the number line, what I have is this. I put my two values there, 0, and I have 1/5. I said it must be less than 0. It is strictly less than 0 because in the question there's no equal to underneath. So I put open circle, less than, I go that way. And then 1/5, greater than that, strictly going that way. And then you are done. So for homework, try the questions in exercise 4.6.2. With this, you really need to practice, and then we will discuss it tomorrow. Do you have any questions, comments? Are you fine? Are we fine, people? What's happening?
Yes, miss.
Okay. Right. So if you're fine, then I will see you guys tomorrow. Okay, so please try those exercises. With this, it's very important that you practice. That is really the key. Okay. Okay, and I'll see you guys tomorrow. Have a good day.
Okay, miss.
Thank you.